Hello everyone, in our C playlist, now we are going to see about the remaining operators, that is logical operator and bitwise operator. So in our previous video we have seen about the basics of C, then operators, arithmetic, relational, right? So I hope everyone understood that. So now we are going to learn about logical operator. So we have three types of logical operator: logical AND, logical OR and logical NOT. So these are basically gates, right? So I hope you already learned that. So we will see one by one about it. So first what we have logical AND, right? So the first operator is logical AND. So AND means what? If the both values are true, then only the output will be true, right? If both the conditions output is 1, then our output will be 1. See, the truth table is, for that we want 2 input and 1 output, right? So if the one condition is false and another condition is false, what will be our final output? False, right? If one condition false, then another condition is true, then what is our output? Our output is false. If one is true and another is false, then also our output will be false. Only if both the conditions are true, then only our output will be true, right? So this is the truth table for our AND, and it is represented as the symbol like this, right? 2 ampersand symbol. So where we use this AND operator? When we are checking two conditions, we will use this AND. So I am giving one example here. So if I want to check 3 less than 5 and in between I am using and I am writing another condition, that is 4 less than 5. Here this condition is true, right? Because 3 is less than 5. And in between them we have AND operator. And if we come to this condition, here also it is true. We have seen in relational operator, right? It will return 0 or 1, right? We can take it as 0 or 1 itself. So here what will be our output? Our output will be 1. So for this also we got 1. So this also we got 1. So 1 and 1. In our truth table what we have as our output? 1, right? So the output will be true. We will get our output like true. So see, we will see another example. Like I am writing 3 greater than 6 and 5 less than 6. So here when we see this condition, 3 is not greater than 6. So it will return 0, right? Because this is false condition. And in between what we are using? AND operator. But when we see this condition, this is true because 5 is less than 6, right? So it will return 1. So if we see in our truth table, what we have 0 and 1? 0, right? So our output will be 0. Only both the condition gets true, then only our output will be true, right? So we will use another example. See, I am having 5 is not equal to 6 and 6 is equal to 6. So here first if you check this condition, this is true because 5 is not equal to 6, right? So it will return 1, right? And we will use AND between them. So 6 is also equal to 6. So then this also the condition is true, right? So it will return 1. So 1 and 1, what will be our output? 1. Then here this is true. So basically we use this logical operators mostly in conditional statement. So we will see this in later classes. So if we can write here any condition. See, if I write here 4 plus 3 equal to 7 and 2 plus 2 equal to. So what will happen? Here 7 equals 7, here double equals, right? This equal to represent assigning operator. This equal to checks the equal values, right? So here 4 equal to 4. Then this is also true, it will return 1. in between them we have AND operator, and this is also true and it will return 1, right? So 1 and 1 we will get true, right? So we will see this in code. For using the AND operator, we are going to write one code. So first I am taking two variables and using scanf I am going to get this variable. What is the formal specifier of integer? %d and ampersand symbol a and ampersand symbol. So what if you missed this address symbol? If you miss this address symbol, it will throw you a segmentation error. Like see, if I run this, see segmentation false, code dump. So here the address symbol is important. So if you miss that, it will throw you an error says like segmentation false. Then we are going to use AND operator between them. So it will return an integer value, right? So like 1 or 0. 1 means true, 0 means false. So what here I am going to write means my a should less than b and it should not equal to b. My a should not equal to b, right? So if we run this, see I am giving like 10 for a and 20 for b. First what will do, it will check for this condition, right? 10 is less than b or not. Yeah, that is true. So here 1 will be stored, right? Then in between what we have AND. So again it will check here, a is not equal to b or not. Yeah, obviously 10 is not equal to b. Then 1 and 1, what we will get? We will get 1, right? So here we got our answer as 1. You can write it any condition. So if you change it to a greater than b and a plus b equal to a. If I give 10, 20. What will happen here? A greater than b. What we will get? It is false because 10 is not greater than 20. Then it will come to this condition a plus b 30, right? So what is our a value? 10. So that is also not equal. But if we minus here, that is b minus a equal to a. Let's see what is happening. So see, we have got 0 because this condition is false and this condition is true. So this will become false and this will become true. How? Because 10 is not greater than 20. But while I am minusing 20 minus 10, it will equal to 10, right? So this condition is true. But our AND operator will give us 1 when the both condition are true, right? So this is also should be true and this also should be true. Then only our output will be 1. So here this condition gets failed. But according to our truth table, 0 and 1, it is 0. That is false, right? So we will print for another. Printf hd. If my a is less than or equal to b and my a is not equal to b. Let's check for this. Giving an output, right? 5 and then 8. So we have got here 1. So how it will now check here? 5 less than 8 or not. So this will become true and then it will check this condition. 5 is not equal to 8. So this also become true. So when both the condition output is true, then our final output will also true, right? So here we have got 1. Understood? So this is about logical AND operator. We will move on to the next operator, that is OR operator. So what is our second type we have? That is OR operator, right? So the symbol for OR operator is 2 lines. So how does this OR operator will work? OR operator gives us one output when even one condition is true. So it will not ask for both the conditions should true. It will give our output as 1 if at least one condition is true. So for OR operator, our truth table is if both the condition fails, then our output also false. If our one condition fails and one condition is true, then the output will be true. If one condition is true and another condition is false, then also the output will be true. If both the conditions are true, then our output will also 1. Right? The OR operator basically works. At least one condition is true, then our output will be true. We don't need to be true for both the condition. Only one condition is true, then our output will be true. So when we see examples like 5 greater than 6 or 3 greater than 6. Here if you see this condition, this is false, right? In between he uses OR operator. But if you see this condition, this is true. So false or true, what we have in our truth table, 0 and 1, we will get true. That is, our output will be 1. So even if single condition is true, the output will be true. So where we use this OR means, we don't know which condition is true. So we will write these two conditions. So check whether single condition is true and then give me the output we are saying. Right? So if I write here like 4 modulus 2 equal to 0 or 4 modulus 2 equal to 1. So which is correct? I don't know. Just tell me, just take one condition as true and print me the output. So first the compiler will goes to this condition and it will say 2 2s are 4, right? So my remainder is 0. So this condition will get true, that is 1, right? Then it will move to this condition. So it will check 2 2s are again 4, but our remainder is 0, right? But what we are checking if it is equal to 1. Then this condition is false here, 0. But we have at least one condition true, right? So 1 or 0, what will be our output? 1. So OR works like this. So even one condition gets true and another condition gets false, it will not consider the false one, it will always return the true if one condition is. Now we will see code for this OR operator. So logical OR, right? So printf %d and I am going to check a greater than b or a equal to b. Calculate the output and give me the final output we are saying, right? So if I give here like a as 4 and my b is 5. So the program will come to this line and first it will check this condition, right? So 4 is greater than 5? No, it is false, right? Because 4 is not greater than 5. So this condition will become false. What we are using in between them? We are using logical OR. So next the compiler will come to this condition. So it will check 4 equal to 4. Sorry, 4 equal to 5. Then this condition also false. So both the conditions are false. Then what will be our output? Our output will be 0. But what if I give one here 4? So now it will check here 4 greater than 4. This is false because 4 is not greater than 4. If I give here equal to, then this condition is true. But 4 is not greater than 4. Then this condition will be false. They are using OR operator between them. And if we check 4 equal to 4, then this will be true, right? So 0 or 1, our output will be 1. Because at least one condition should be true, right? Then our output will be true. So we will run this code. So say I am giving 5 and I am giving 4. So what we have as our output? 1, right? Because here it will check 5 greater than 4 and this will become true. But when it comes to this condition, it will become false because 5 is not equal to 4, right? So this is how the OR operator works. It will give the output as true. At least one condition is true, right? So I hope you understood this OR operator. So we will move on to the next operator. So what we have our next operator means, so we have not logical not. So its symbol is exclamatory mark. So what does this not will do? It will just give the complement of that number. If we given 0, it will give 1. If we give 1, it will give 0. So apart from 0, if we flip the any of number like 5 or 6, it will return 0 only. So only if you flip the number like 1, it will give 0. If you flip the number as 0, it will give 1. So if you flip the number 7, it will give 0. 8, 0. Only if you flip the number 0, it will give 1. Other than that, no number will give the 1. So 0 means 1, 1 means 0, 5 means 0. Up to any number you can write. The number if you perform not operator, it will give 0 as the output. Understood? How we will write mean? For example, so I am initializing one variable with 0. And if we print it with not operator, something like not A. So what will be our output? Here our output will be 1. This not will perform the complement of this 0. So here it will give the not of 0. So not of 0 means it will convert into 1, and in our output scale we can see 1. So let me see in our code. So printf %d, then what we are going to do? Not of 0, and again printf %d not of 1, and we are going to check for other numbers like 5, 4, 3, not of 3. So here what will be our output? 1. Here 0. Here 0. Right? So we will leave some gaps. When I run this, asking for the input. Now when we run this, we have got the value 1, 0, 0. Right? So 1, 0, 0. So if you flip any of the number other than 0, it will lead to 0. So if I flip the number 13, so now also we get 0 only. Right? So this is our not operator, how it works. So I hope you understood this not operator. So we will move on to the next topic. So next what we have is assignment operator. So what are the types of operators? So these are the assignment operator. So already you are known this equal to we'll use for assigning the values to the variables, right? So we will assign the values using this single equal to operator. So what this plus operator will do? So if I given here a plus or equal to 1. Now what we have in our a? We have 6, right? So if I write this line means, so if we expand it means a equal to a plus 1. So this is the shortcut of this. So we are performing basically this operation but in our shortest way. So here a equal to 6 plus 1 we will get 7, right? So same the output we will get from here. That is a plus 1 equal to 7. So this is the full line of expression. We have become it short. So how this line will represent? A minus equal to 1. So what value we are minusing or adding? That should be after the equal to, and the arithmetic operator should be before the equal to, right? So this will represent a equal to a minus 1, right? So what we have in our a? 7, right? So 7 minus 1 we will get 6. So if we want to use this star means a star equal to, then a equal to a into 2. So this is what this line is saying. So we have 6 in a, right? So 6 into 2 we will get 12, right? Then we have another assignment operator, that is divide equal to 2. So here it is what represents a equal to a divided by 2. So we should use like this shortcut only if we are doing the operation with same variable. See, if you are doing with like different variables means you should do like a equal to b divided by a. Only the same variables can use this assignment operator shortcut, right? So if we divide it means 12 divided by 2. So now in our a we have 6, right? So we will code this. We are going to create a new file, assignment.c. Then our structure include stdio.h, then int main, where our course get started, right? Then return 0. So we are going to take one variable, then using scanner we are going to get those variable, and now we will perform the addition assignment operator. So a plus r equal to 2. So if I given here a equal to 6, so the compiler will come to this line, and what it will do? A equal to a plus 2, right? So what we have in our a? We have 6 in our a. So plus 2 means now in our a we have 8. So if we want to print means print of %d. Then we are going to check if our a is incremented or not. So if we give the a as 5, so it will add 2 to it and give us the output 7. So see, we have got 7. 5. So 5 minus 2, 3. So what will happen here? If we given the input as 5, so now it will do the operation minus a equal to a minus 2, right? Then 5 minus 2, our output will be 3. Understood? So what if we want to multiply it? So I am going to multiply it by 6. So if I give the input as 3, then it will perform a equal to a into 6. Then 3 6 are 18, right? So see, if I run this and I am giving output as 3, and see we have get here 18. I am giving 7. So 7 6 are 42. Okay. So if I want to do division, so what this division will return as quotient, right? So if I run this, so I am giving 12, and what output we will get? 2. Because 12 divided by 16, we will get 2, right? So basically this will do a divided by 6. That is 12 divided by 6. Our output will be 2. Understood? So same for modulus. So a modulus equal to, I am going to do it 2. So if I given the a as 6, and what will happen here? It will perform a equal to a modulus 2. Then our output will be a modulus 2. What remainder it will get? The remainder will be 0. Because 2 3s are 6, right? If we minus 6, we will get 0. So see, I am giving the input as 6, and we have got 0 here. Understood? So this is assignment operator. I hope you understood. So we will move on to the next topic. So next is increment or decrement operator. So we have two type of increment, that is pre-increment and post-increment, right? So we have two increment type. So one is pre-increment and the next one is post-increment, right? So pre-increment means plus plus variable name. Post-increment means a plus plus. So what is the difference between them? So first we will see what is increment. So if I given here 5, then I am incrementing it and then I am printing. So what will happen here? So first initially my a is 5. So when the compiler reaches here, it will increment by 1. Increment by 1 means it will add 1 to our a, that is 5 plus 1 will get 6. So basically, how many times you run this code? So if again I am adding here a plus plus, again I am adding a plus plus, again I am adding a plus plus. Then I am printing my a. So what will happen here? First, it is 5 right initially. Then it will come to this line. Then it will add 1 to it. Then it will become 6. Right? So again it will, when it's a increment. So now we have 6, right? So 6 plus 1, 7. So again it comes to this line, and when it's the increment, so 7 plus 1 will get 8. So finally it will print 8. So this is what increment is called. So first we will see pre-increment. So what does pre-increment is? So first, if I taken a equal to 5 and we write here pre-increment. So first it will increment to 6. Then it will printf. See, if I write in printf %d and I write this pre-increment. So what will happen? So in our A we have 5, right? So when it reaches the statement, it will go here. So first it will increment. So when the compiler see this plus plus, it will just increment to 6, and then it will go for this A, and the 6 will be printed. Understood? So taking another example, if my A is 7, right? So if I print it, first increment, then print it, I am saying. So when it reaches to this printf, so it will goes to this line, and first it will increment my a value, that is 8, and then it will goes to this a and it will print a to the output screen. But this is pre-increment, okay? Post-increment means it will first print the a, then it will increment, right? So first I had given the a equal to 5. So if I print that, a plus plus, so here directly first what will my compiler see? My compiler will see this a, and in a we have 5, right? So first it will print the 5, then it increment in the background, right? It will increment in the background. See, then if I write another printing statement and print the a, just a, that it will print 6 for me, because first it printed, then it incremented, right? So this increment value will be printed in the next printf. So this is the difference between pre and post increment. So we will see with one example. So see, I am taking int a equal to 4. Okay. So in my first printf I am writing plus plus a. Okay. Let's see what is our output. So here we have already declared. So see, we have got our output as 5. So this is pre-increment. Before printing, we are incrementing it. So if I write the post increment, so first I have 4 in my a, right? So at pre-increment it is incremented to 5. Then when it's come to this 12, it will still print the 5. Then it will increment. So when the compiler see the first variable, then the plus plus, so it will first take this variable and it will print. Then only it will increment the a value. See, we will check this. So see, both the time I have got the same value, that is 5. So if I print again the a value, then it will give me the 6, because here it is incremented, right? So now my a will become 6 here. So if I printed here, my output will be 6. So wait, we will run in use. So see, if I printed 556. So in the pre-increment, it will first increment, then it will print. In the post-increment, first it will print, then it will increment. Right? If you want to see the post-increment value, just print that variable again. Then you will see the post-increment value. So I hope you understood this increment operator. So we will move on to the decrement operator. So decrement, right? So in decrement also we have pre-decrement and post-decrement. Same like the increment. So minus minus A. Then A minus minus. So first pre-decrement means if my A is, I have write 5. So if I print pre-increment minus minus A. So what will happen here? So first the compiler will go here and it will first see this minus minus 8. Then it will first decrement to 4. So my A value is now become 4, right? Then it will print the 8 here. That is 4 in the output. Right? Same like increment only. So what is post decrement? So if I printed the A, so what we have in our A? We have still 4, right? So it will still print the 4. Then only it will decrement to 3. So if I again print the A variable, that is not decrement, I am just printing the A. Then it will give me 3. Understood? So see, so first I am printing the pre-increment, that is minus minus A. Then I am printing post-increment A minus minus. So here what will be our output? Our output will be, see, 3. In the post-increment also it is 3. So now I am printing the A variable. So now see what I have got, 3, 3, 2. Because it decrements here, right? So first it is printing and then it is decrementing. So this is how increment and decrement will work. So I hope you understood this. We will move on to the next topic. So this conditional ternary operator we will see in the coming classes. So now we are going to see about bitwise operator. So we have 5 types in bitwise operator, that is AND, XOR, NOT, left shift and right shift. So we will see one by one. Okay. So now we are going to see about bitwise operator. So before learning bitwise operator, you should know basic conversion of decimal to binary and binary to decimal. Right? So first we are going to learn that conversion, then we are going to learn about bitwise operator. So conversion, decimal to binary. Why we are learning this? Because bitwise operator will work in binary values. So what is known as this decimal? So 0 to, so the numbers are known as decimal. Like 0, 1, 2, 4, etc. These are decimals. So binary means binary value is represented as zeros or 1. So I hope you know our computers only understood binary. So now we are going to see about bitwise operator. So before learning this bitwise operator, you should learn how to convert a number to a binary. So we will learn first the conversion, then we will come on to this operator. So now we are going to learn about numbers to binary conversion. So why we are doing this conversion? Because bitwise operator will work in binary values, that is zeros and 1. So number means 0, 1, 2, 3, 4, right? So we are going to convert these numbers to base 2 value, that is zeros and 1s. So basically our numbers will have base 10. So we are going to convert it to base 2. So how we are going to do that? So first if we take one number as 5. So how we are going to find the binary value for this number? So we want to continuously divide this number by 2 until the remainder is 1 or 0. So if we divide it, we will divide it by 2, right? So 2 2s are 4. Here what will be our remainder? we have remainder as 1, right? So again if I divide this 2, so 2 ones are 2, my remainder is 0. So we will collect this remainder. So if we look like bottom to up and we write 101. So this is the binary value for 5. So 5 with base 10 is equal to 101 with base 2. So this is how we are going to convert the numbers to binary values. So if you take another number like 7, so it is in base 10, right? So we will convert in base 2. So first continuously you need to divide it by 2. So 2 3s are 6, right? So what is our remainder? 1. Then 2 1s are 2. So if we divide this 3, so 2 1s are 2, our remainder will be 1, right? So we need to check from bottom to up. Then we will write this remainder like this, from bottom to up. So this is the binary representation of the base 10 value 7. So 7 base 10 value is equal to 111 binary value. So if you want to see another example, we are taking 9 the base 10 and what will be our base 2 value. So we want to continuously divide it and we want to collect the remainder, right? So 2 4s are 8. 2 4s are 8, our remainder will be 1, right? Then 2 2s are 4, our remainder will be 0. Then 2 1s are 2, our remainder will be 0. So we need to look from bottom to up. So our binary value will be 1 0 0 1. So 1 0 0 1, right? So this is the binary value for 9 with base 10, right? So if you want to see another example, so I am writing 11 here in the base 10. Okay. So 11, 2 5s are 10, right? So my remainder will be 1. Then 2 2s are 4, my remainder will be 1. Then 2 1s are 2, my remainder will be 0. So bottom to top, my binary value is 1 0 1 1. Base 2 for 11 in base 10, right? So this is how we are going to convert a number to a binary value. So we have learned how to convert number to binary value, right? So now we will see about how to convert a binary value to a number. So now binary to number, right? So if I take some binary value like 1 0 1 1. So how we are going to convert this to base 10. So we have seen how to convert from base 10 to base 2, right? So now we are going to see about base 2 to base 10. So first we need to take our binary value. So from right to left, wherever the 1 present, we are going to calculate those values. Starting from this right corner, we need to multiply it with 1 into 2 power 0. Then with 1 into 2 power 1. Then 0 into 2 power 2. Then 1 into 2 power 3. So if you find the value for this, 1 into 2 power 0 means 2 power 0 will be 1, right? So 1 into 1, our output will be 1. Then 1 into 2 power 1 means, that means 1 into 2, our output will be 2. Then here 0 into anything, 0. Then here 1 into 2 power 3 means 2 power 3 means 8. So 1 into 8 we will get 8, right? So you need to add this. So 2 plus 8 we will get 10. and we add 1, it will result the 11. So 1011 in base 2 will give us 11 in base 10. Right, so this is how we are going to find binary to a number. So if you want another example, like 1101. In base 2, we will find to base 10. So first we need to take our binary value. Then what we want to do? We want to start from our right end and we want to start multiplying with 2 power 0, right? Then next with 0 into 2 power 1. Because this is base 2, we are multiplying it with 2, right? So again 1 into 2 power 2 and 1 into 2 power 3. So if we calculate this, so this will become 1, 0, 2 power 2, 4, right? So 1 into 4, we will get 4 and 2 power 3 we will get 8, right? So 1 into 8, 8. So if we add it, what we will get? So 8 plus 4, 12, 12 plus 1, 13. So 1101 in base 2 is equal to 13 in base 10. Understood? If we see another example like 101 in base 2, what will be the value in base 10? So if we first take our binary value, start from the right end. That is, we should start from this 1. Right? So we need to start multiple with 2 power 0. Right? So 1 into 2 power 0 is equal to 1. Then 0 into 2 power 1 we will get 0. Right? Then 1 into 2 power 2 we will get 4. Because 2 power 2 is 4 and if we plus it we will get 5. So 101 in base 2 is equal to 5 in base 10. So this is how we are going to convert a binary number to numbers in base 10. Okay, so we have seen about the conversion of number to binary value and number binary to number, that is base 10 to base 2, base 2 to base 10. Okay, so now we will see about bitwise operator. I hope you understood this conversions. So now we will see about bitwise operator. So in that we are going to see the first type, that is AND. So the symbol is single ampersand symbol. So we already seen about the truth table for AND, right? So 0 and 0, the output will be 0. So 0 and 1, the output will be 0. 1 and 0, the output will be 0. Only 1 and 1 will be, the output will be 1. Right? So other than the others are 0. Only 1 and 1 will be 1. So what we are doing with these values? So first I am going to take two variables like int a and b. I am taking int a equal to 3 and b equal to 5. Right? So what this bitwise will operator do means, if I compare like this a and b, so it will perform the AND between this 5 and 3 and it will give some binary value. And that value will be converted into number and it will return to our output screen. So if I print it like this, it will perform binary operator and it is converted into the zeros and ones. And then it will converted into the number. Then it is printed in my output screen. So what is happening here? First we will take 3 and 5. Okay. So first convert this 3 to binary value. How we are going to convert? We are going to convert like 3. So 2 ones are 2, right? So the remainder is 1. Then bottom to up, our binary value for 3 is 11. Then AND for 5. 2 2s are 4, the remainder is 1. Then 2 1s are 2, the remainder is 0. So for 5, the binary value is 101. So we will perform AND in between these two binary values. So here I have two values, right? So don't worry, just add 0 before them. Then 101. Then do the AND operation for this two binary value. So in our truth table, so this is our truth table 0 0 0, right? 0 1 0, 1 0 0, 1 1 1. So 1 and 1 means what we have? 1, right? So here 1. So 1 and 0 0. So 0 and 1 0. So finally what we have? 1, right? So this is our final binary value when we do AND operator between 3 and 5. Then we want to convert this to number, that is base 10. So this is my binary value. So how we are going to convert binary to base 10 value? So we are going to start from right. So we need to multiply starting with 2 power 0, right? Then 0 into 2 power 1. Then 0 into 2 power 2, right? So here it will 1, here 0 0. And if we add them, our output will 1. So finally 3 and 5, my output will be 1. Understood? So don't worry, we will see another example. Like I am taking A as 6 and B as like 4. So first A and B, right? So 6 and 4. So we need to first find the binary value for 6. The compiler will find. I am just telling how it is running. So first we need to divide it by 2. Then 2 3s are 6. My remainder will be 0. Then 2 1s are 2. Remainder will be 1. So we want to look bottom to up. So our binary value for 6 is 1 1 0, right? Then for 4, 2. 2 2s are 4, 0. 2 1s are 2, 0. Right? So bottom to up 100. So in between this binary value, we want to perform bitwise AND operator. So 0 and 0 means 0. 1 and 0 means 0. So 1 and 1, 1. So this is our final binary value, 100, right? So again we need to convert this binary value to base 10 value. So we are going to convert 0 into 2 power 0, 0 into 2 power 1, then 0 into 1 into 2 power 2. So here it is 0, 0, here it is 4. So finally 6 and 4, it will give the output as 4. So don't confuse, it is giving the same value as it is. We will see another example. So I am taking A as 7 and B as 8. So first 7 and 8, right? So first we need to find binary value for this 7. So 2 3s are 6, 1 will be remainder, and 2 1s are 2, 1 will be remainder. So bottom to up, my binary value for 7 is 1 1 1, right? So then for 8, 2 4s are 8, my remainder will be 0. Then 2 2s are 4, my remainder will be 0. 2 1s are 2, my remainder will be 0. So bottom to up, we have 1 0 0 0, right? If we don't have a number, right, so we will put here 0. So 1 and 0, 0, 0, 0. Here also we have got 0. So 7 and 8, the value is 0. If we perform the bitwise AND between them. So another example we will see, like A equal to 3 and B equal to 9. So first what we want to do, we want to convert them into binary. So 2 1s are 2, the remainder is 1. 11 and then 9. 2 4s are 8, my remainder is 1. 2 2s are 4, my remainder is 0. 2 1s are 2, my remainder is 0. So bottom to up, 1 0 0 1, right? So 0 0 here. If we perform AND here, so 1 and 1, what we will get? 1. 1 and 0, 0. Here also 0, here also 0. So final answer is 1. So 3 and 1, the output will be 1. So we will see this in code. Okay, I hope you understood this explanation. We are going to see bitwise operator. First for AND. Right? Then we are going to take two variables A and B, and using scanf we are going to get from user. We are going to perform bitwise AND between them. So what they will return? One integer, right? Then A and B. So if we print it, so I am giving 3 and 9. So see, we have got 1. So now only we did this example in the explanation, right? So if we again give 7 and 8, see 0. See 7, 8, we said right? 7, 8 equal to 0, and we done right 3 and 9 equal to 1. So same answer, right? So this is how we are going to perform the AND operator. The next is OR operator. So now we are going to see about OR operator, bitwise OR. So the symbol is single line. I used double, right? So here we are going to use single. So what is the truth table for OR? 0, 0, 0, right? So 0, 1, 1. 1, 0, 1. 1, 1, 1. Even if the single condition is true, then the output will be true, right? Even there is 1, 1, then it will become 1. So I am taking A equal to 4 and B equal to 5. So if we perform OR operator with them, then 4 or 5. Then first we want to convert it to binary, right? So 4, 2 2s are 4, the output is 0, 2 1s are 2, the output is 0. So the binary value from bottom to top is 100, right? Then for 5, we have 2 2s are 4, the remainder is 1, 2 1s are 2, the remainder is 0. From top to bottom, 1 not 1, right? So if we do OR here, what will we get? 0 and 0 or 1? 1. Because we have 1 here. At least 1 should present, then our output will be 1. So 0 and 0, 0. 1 and 1, 1. So if we convert them to number means, so see, same as 5, we have got our final binary also. So 4 or 5, our answer is 5. Okay. So we will see another example. So I am taking A as 7 and B as 9. So 7 or 9. So first for 7 binary, 2 3s are 6, 1 is our remainder. So 2 1s are 2, the remainder will be 1. Right? So the binary value is 1 1 1. For 9 it is 2 4s are 8, 1 is remainder. 2 2s are 4, 0 remainder. So 2 1s are 2, 0 remainder. So 1 0 0 1. So 1 and 1, 1. 1 and 1 or 0, 1. 1 or 0, 1. So here also 1. So if we find number for this, so what we have said, we need to multiply with 2 power from the right to left, right? So 1 into 2 power 0, 1 into 2 power 1, 1 into 2 power 2, 1 into 2 power 3. So if we calculate them, 1, 2, 4, 8. So if we add them means 10, 14, 15. Right? So our output will be 15. So 7 or 9, our output will be 15. Okay, hope you understood this. Now we will code it. So instead of doing here and, I am going to do or. Okay, we will run this. So 7, 9. So see, we have got 15. So same value we have got here, right? So again I am running this for 4 and 5. See, we have got 5. If you want to try with new numbers, so I am giving 9 and then 10. So you see, we have got 11. Right? Hope you understood. So we will move on to the next bitwise operator, that is XOR. So the third bitwise operator is XOR, represented as this cap. So the truth table for this XOR is A, B and our out. So 0 and 0 means 0. 0 XOR 1 means 1. 1 XOR 0 means 1. 1, 1, 0. So it is actually gives the output as 1 when the both the inputs are different. That is, it should not be same, like 0 and 0 and 1 and 1. If it is same, then it will give the output as 0. It should be opposite, then only it will give the output as 1. So if we calculate for x equal to 11 and b equal to 5. So first what we will have, 11 XOR 5, right? So for 11, what is the binary value? So 2, 2 5s are 10, 1 will be remainder. 2 2s are 4, 1 will be remainder, 2 1s are 2, 0 is remainder. So our binary value is 1 0 1 1, right? So for 5, 2 2s are 4, 1 will be remainder, 2 1s are 2, 0 will be remainder. 1 not 1. So I will write here 0. So 1 and 1, what we have? 0, right? So 0. 1 XOR 0, 1. 0 XOR 1, 1. 1 XOR 0, 1. Because opposite value gives output as 1. So this is our final binary value, that is 1 1 1 0. So if we want to convert in number means, so now we are doing like 0 2 power 0, right? So now I am going to tell another way to convert the binary to number. So that is, so in top you just start from right and give the value as 1 2 4 8 16 32 64 128, right? So this is up to 8 byte or bits. So now we have up to this only, right? So memory this number, okay? So in our binary number, where and all we have 1. So add those number straight to that. So here we have 3 numbers, right? 3 ones. So add those. So 4 plus 2, 6. 6 plus 8, 14, right? So our answer is 3 XOR 5 is 14. See, you can do this way also. See, 0 into 2 power 0, 0, right? So 1 into 2 power 1, 2. 1 into 2 power 2, 4. So 1 into 2 power 3, 8. See, same, 2, 4, 8. So instead of doing such calculation, write the numbers like this and cut it up to which number you have. Then add those numbers. Then we will get the value. So we will see another example. So I am taking A as 15. Then B as 7. So I am performing XOR between them. Right? So first I am taking 15. Then 2 7s are 14. Remainder is 1. 2 3s are 6, remainder is 1. 2 1s are 2, remainder is 1. So from bottom to up, my binary value is 1 1 1 1, right? So for 7, what we have? 2 3s are 6, remainder 1. 2 1s are 2, remainder is 1. From bottom to top, 1 1 1. Then here 0, right? So if I do the XOR here, 1 XOR 1 0, 1 XOR 1 0, 1 XOR 1 0, 1 XOR 0, that is 1. So we have our final binary value, right? 1000. Sorry, 1000. So now we will write the number on the upward, like starting from 1 2 4 8. So we need to add where the 1 is present, right? The 1 is at here. It represents 8. So our final value between 5 XOR 7 is equal to 8. So now we will do our XOR in our program. Okay. So XOR symbol is cap, right? So if I run this and if I given 15 and 7, see my output is 8. So see, we have got your 8, right? And if you want to try with another number, there's 23, then 6. So see, we have got 70. And our last bitwise operator, that is not. So not means nothing. It will just give the value if we perform. It is not between two operands, it is only one operand. So if I give, so it is based on single input, percentage %d and ampersand symbol A. So I want to perform the not, right? So percentage %d, not means this symbol, then variable name. So what does it do means, not means, so minus of n plus 1. So not returns this value. So if I give the, like if I give here 6, so what it will gives me? Minus 7. That is here A. Okay, change the variable. N or A, anything. So 6 plus 1, that is 7, right? And it will apply minus to it. So minus 7 will be our output. So if I run this, I am giving 6 and see I have got here minus 7. So don't worry, running this again. See, 6 I given minus 7. If I give 8, so it will give me minus 9. See, I have got minus 9. So this is how the NOT will work. So I hope you understood this session. So that's all about the bitwise operator. So we will see in our next video. Thanks for supporting us. So subscribe for more videos. Thank you.